So today we have a fun geometrical problem. The given data is very simple, there is nothing to be explained. Now the point to be noted is that in the thumbnail you have seen that yes, the area of this and this was given. We have to find the area of this middle one. But what if that area differs, means the area in the thumbnail was 2 and this was 4. But what if they are 6 and 12, they are 3 and 4, that's 5 and 7, means they are different. Then what we have to do? Or else if this and this is given, we have to find this and this is given, we have to find this one. So it's all based upon like we have to just play with these three squares. Either area of 2 will be given, we have to find the third one, or else they can be in variable also. Then what we have to do in such a case? So for such a case, we need some kind of beautiful relation between these three square. Either they are sides, or either they are area, either they are perimeter, anything. But there should be some kind of beautiful relation between this and this. So if we will find a very beautiful relation between these three, then any of these two must be given, then we can find the third one. So the main motive in this video will be there to derive a beautiful relation between these three. So let us see that. So first of all, as we can see, there's an isosceles right angle triangle. As these two sides are already equal, so and there's 90 degrees, so this type of right angle triangle is known as isosceles right angle triangle. So the other two angle becomes 45 degree and 45 degree very nicely. So this is one of the corner of right angle triangle, so 45. That is the other corner, so that's also 45. Let this angle be equals to alpha, let that angle be equals to beta. Now by the angle, we can say exterior angle property. If there is a triangle, the base is extended, these two angles are A and B. And if this is a straight line, then this angle is nothing but it's A plus B. So that is called as the exterior angle property. So look, in this particular triangle, this is a straight line. The opposite two angles are already 45 and alpha, so its addition will be that angle. So that angle ultimately forms 45 degree plus the alpha. Let it be clear, yes. So that angle over there becomes 45 plus alpha, yes. Now what about this angle? This is the exterior angle for this particular triangle. The two of its opposite angle are 45 and beta, so it ultimately forms 45 plus beta, yes. Writing it a clear one, so it's better to see. Let the color be changed. So this is 45 plus beta, yes. Now we have to just utilize this data. That means what we have done is just the utilization of this given data, nothing else, not very special thing just now. These two sides are equal, so let us mark them as equal. Let it be equals to something like k, or else let it be anything. Let it be a very nice variable, so let them in equals to a and b. Not as they are equal, we have to just mark them equal, so let it be equals to k and k. Yes, that is good. These both are equal, so k and k. This and this side we have to just name it, so let it be named as m and n. These three are the squares, so let us name their sides also. So let the side of this be equals to b, or else a, starting with a, this as the b. Let it be clear, yes. This as the b and this as the c. So these three square, the sides have been marked a, b, c, and as they are square, all the four sides are equal. So this is also equals to a, this also a, this much length is also equals to a. Similarly over here, all the properties of the square, that all the sides are equal. Now we will utilize this much things to just have some kind of very beautiful things. Let us name this triangle also, all these parts, so very quickly. Yes, so we have over here named all these things. Now in this particular diagram, look at this particular triangle. The triangle I am talking about is triangle B. Let it be clear, yes. In this triangle B, E and C. Triangle B, E, C. Look in this diagram, that's from here to here, and this particular triangle. Let us redraw that triangle over there. Yes. This corner is nothing but it's 45 degree plus alpha. You can also look in this diagram also, the main diagram simultaneously. So 45 degree plus alpha, this corner is B, this corner is E, and this corner is C. So this angle at B is 45 plus alpha, this complete angle. This angle is single times 45 degree, and the top angle it's 45 degree plus beta. So writing it there clearly, 45 degree over there, and this angle is nothing but it's 45 plus beta. Now let us name the sides. So BC is equals to K, yes. EC is nothing but it's this much length plus this much length. This length is equals to C, this length is equals to B, as these are the sides of the square. So this complete length becomes B plus C, yes. And this complete length, it's nothing but we have named as N in this diagram, so that is equals to N. Now what we will do is use the sine rule. Yes, the sine rule says that if there is a triangle, the angles are A, B and C, and the opposite sides are P, Q and R. Then sine of A upon its opposite side, that is Q, is equals to sine of b upon its opposite side, that is equals to r, and that is equals to sine of c upon its opposite side, that is equals to p. So this is the sine rule. If there's a triangle, the three angles, the three sides, so sine of that particular angle upon its opposite side is equals to sine of the another angle of that same triangle upon the opposite, like that way. So we will just use this sine rule in this triangle. So starting with sine of 45 plus beta, so sine of 45 plus beta, the topmost angle, so sine of 45 plus beta upon its opposite side, that is equals to k, is equals to sine of 45 plus alpha upon its opposite side, that is b plus c, and that is equals to sine of 45 degree and its opposite side is equals to n. So we have this, means this kind of relation between the sine of this angle and all these things. So now let us see another triangle. Now another triangle I am just going to take is, first let me write and then I will tell you. Means you can just have a simultaneous look in this diagram. I am just removing this sine, what is sine rule from here. This all the small things you have to just keep in our mind if you want to master geometry or anything. Sine rule, the cosine rule, all these things. So now look at this triangle, that is triangle, I am drawing it over there. Triangle, it's in the diagram A, B and D. Yes, in this triangle A, B, D, that's A, B and D. In that triangle, angle A is 45 degree. This angle B is 45 plus beta. Yes, let it be clear. Yes, it's 45 plus beta. Let me zoom it and show you. A, B and D. You can have look A, B, D. A, B and D. Here this complete angle is 45 plus beta, that's 45, and this angle is 45 plus alpha. So over here also this angle becomes 45 plus alpha, so 45 plus alpha. Now we have to mark its three sides and again use the sine rule. So in this diagram the value of AB is equals to K. Yes, the value of AD is this much length plus this much length. This much length is already equals to A, this is equals to B, so the complete length becomes A plus B. So writing it over there, so this complete length, that's from A to D, it's become A plus B, and BD is equals to M according to this diagram. Now let us use the cosine rule, not the cosine rule, the sine rule again. So sine of 45 plus beta, that's this angle, sine of 45, not 145, 45. Yes, sine of 45 plus beta, that's angle over there, its opposite side is A plus B, that is equals to sine of 45 plus alpha. So 45 plus alpha upon its opposite side, that is K, and that is equals to sine of 45 upon its opposite side, that is equals to M. Yes. Now these two things we have just derived from these two triangles, this relation and this relation. So in this relation and in this both relation, what I can just observe is that it also contains sine of 45 plus beta, sine of 45 plus alpha, just excluding this is not required. Yes, as why it's not required, because the variable marked over here is n and m, and they were not so important in this diagram because we marked them, but these things were important because as it was given that this right angle triangle is an isosceles right angle triangle, then and then only we got 45 plus beta, 45 plus alpha, the two sides are equal k, and the squares were the most important, so their sides are also included over here, a, b, b, c. You can just have a look. So these two things means they were not, it was generated, but it was generated by ourselves, but these two things are important. So here we can see sine of 45 plus beta, sine of 45 plus alpha, and here also we can see sine of 45 plus beta, sine of 45 plus alpha. So from here I can have the ratio, that is I will just shift k over there and sine of 45 plus alpha over here. So I can have that sine of 45 plus beta upon sine of 45 plus alpha is equals to k upon b plus c. Yes, similarly in this below also I can shift, I want the 45 plus beta on the top, so it's already on the top, I can shift it over there and a plus b over there. So from this equation I will get that sine of 45 plus beta upon sine of 45 plus alpha, and that is equals to a plus b upon k. So writing that over here, a plus b upon k. Now we just derived this, first of all just these three equations from the sine rule. It's not like a equation, it's like the equality. So from the sine rule we derived this and this, that's the top and bottom, and from that a little kind of modifications, we got this and we got this. And now what we have obtained, we can just have a clear look to see that yes, their LHS is all equal, that's sine 45 plus beta, sine of 45 plus alpha, sine of 45 plus beta and sine of 45 plus alpha. So there are two equations, their LHS is already equal, so we can compare their RHS. So RHS of the first one is k upon b plus c, and RHS of the second one is a plus b upon k. We can do the cross multiplication from here, so we get that k square is equals to ab plus ac plus b square plus bc. This multiplied with that, so this term multiplied with this term gives me that thing. So what we have is the value of k square. Now remember the thing that we have not utilized till now. Look carefully, remember what thing we have not utilized till now. The thing we have not utilized is, first of all, what we have utilized. The side of the square very nicely, yes. The angles were 45 degree, yes. The sides equal, that is k and k, that also. But what we have not utilized till now is that this particular triangle is a right angle triangle. That angle over there, angle B, is completely a 90 degree that we have not utilized. So let us utilize that. So this is a right angle triangle, the sides are k and k. The hypotenuse, its complete length will be side length of first, side length of second, side length of third. So its complete length become a plus b plus c. So if there is a right angle triangle, the only thing we can do is the mightiest theorem, that's the Pythagoras theorem. So k square plus k square is equals to a plus b plus c the whole square. Now remember that we just obtained the value of k square in terms of ab, means in the terms of abc. So there are 2k squares, so all we have to do is multiply this both the sides by 2. So writing it over there, so 2 times AB plus 2 times BC plus 2, let it be clear, yes, it's BC. 2 times BC plus 2 times CA plus 2 times B square is equals to A plus B plus C the whole square, that is nothing but it's A square. First of all, writing it as A plus B plus C the whole square. Now writing them clear over here. So on the LHS we have that 2 times BC plus 2 times CA plus 2 times AB plus B square, sorry, plus 2 times B square, yes, plus 2 times B square is A plus B plus C the whole square. That's a very nice identity, and it's equals to A square plus B square plus C square plus 2BC plus 2CA plus 2AB. Yes, now from the both sides I can see 2BC, 2BC, 2CA, 2CA, 2AB, yes, CA, I forgot to write the A. So 2CA, 2CA, 2AB and 2AB got cancelled out. This B square come over here, so negative b square, so 2b square minus b square gives me b square, and that's equals to a square plus c square. And remember what this resembles, b square is equals to a square plus c square is the relation that we were finding. The sides of this particular square slide was over here, this, let it be clear. So hypotenuse, this was the smallest square, this was the biggest square, and then we have this square. So its side was a, its side was b, its side was c. So if the side is a, its area becomes a square. If the side is b, so its area becomes b square, and if side is equals to c, its area becomes c square. So a square, b square, c square is nothing but it's the area of these three squares particularly. So what we derived is that the area of this middle one, as middle one was marked as b, so area of this middle one is equals to area of additions of this both, the other smaller ones. So this was the relation we were trying to find. So in this diagram, I'm just zooming it over there and clearing all this stuff. So remember that yes, that 45 degree, the specialty of this was that it's an isosceles right angle triangle. This angle 45 degree and opposite sides were equal. Not the opposite side, isosceles right angle triangle means the same. And its area was 2, its area was 4, and we were looking to find this. And as we have derived the equation that area of this plus area of this is equals to area of this, so 2 plus 4 is equals to 6, and that's our answer, that area of this middle square is equals to 6. What if the 2 and 6 were given and we have to find the 4? So we have the relation that 2 plus x is equals to 6, so ultimately we get that x is equals to 4. So that was a very nice relation. Either of these 2 are given, we can find, or else in some kind of variable they are given, we can find the value of that thing. So b square is equals to a square plus c square is the relation, or we can see the beautiful equation between these 3 squares. So this was my method to solve this particular equation. If you have any other method other than this, you can do comment below, or else you can DM me on my Instagram, link is in the description, or else you can email me also, this is also given in the description. So if you found my problem interesting, you can do subscribe to the channel also. So if you send me a solution and I found it very nice and more shorter and elegant than my method, I will again make a video so that the viewers can see it and express the knowledge.